ahead and do that. Yeah, so this'll just be an update of things in flight and or things that have happened in the last 2 months or so since I last spoke to this group. There's a sort of an arbitrary laundry list of stuff that's been added. There's case statements that got added finally. There's been some improvements for the Bluetooth serial terminal, and there's some words that will help folks manipulate the storage in the device a little bit more easily without somersaults. And then there's some progress towards code words and dump, and some improvements with the camera, and one additional hook I added last night, actually for the user words feature that Peter uses. So, so let's talk about case statements. So, Forth case statement was something that's not all Forths have this one, but it seems to be pretty widely used, and I actually sort of felt the absence of it in ESP32 Forth because of a coding challenge that Bill Ragsdale did at the last SVFig meeting, and it was a conversion from numbers to sort of spelled out numbers, and it was possible certainly to do without case statements, but case statements end up making it a little bit more terse. So I've added this to the set of built-ins in the bleeding edge version of ESP32 Forth. When you have something like this piece of code, it will underneath sort of at compile time get transformed into an if tree, and will sort of splay things out. Nothing particularly deep. I mean, it's been implemented in all at high level Forth. The main advantage of the syntax is that it's terser when you're branching on a value.
Presentation now, I'm gonna leave.
It got me thinking a little bit about how case statements work in Forth, and sort of thinking about how that relates to other languages. In C in particular, case statements are kind of, or switch statements are, one of the sort of underlying goals is that it can automate the creation of a jump table, whereas in Forth they're more of a the syntax sort of prescribes that they end up being more of an if-else. But it's so close. It's actually maybe with some careful choices about transitions from compile to interpret time, it's got me wondering whether a small variation on the ANSForth case statement would allow for the construction of a proper jump table, where the C compiler will, on a switch statement, if there's dense sections to the values that you list, it will arrange things so that it will do a mask operation or a branch around it, and then look up each possible path in a table, which can be more efficient. So maybe worth exploring. Although typically in Forth, when you do a jump table, you just do it explicitly with create and tick and so on. So not particularly Forthy, but got me thinking about whether or not the ANSForth words are sort of had that as a design goal or not, which I imagine there might be folks out there that would know what the history is and the choices for those words. Another one I'll flag. I don't think I'm going to demo it just because too many things to talk about, but for those that use the Bluetooth serial terminal, I noticed that it wasn't working on a regular ESP32 Forth. I tend to use it for my own purposes primarily with ESP32 Cam, and that one has a little bit more memory, and so it ends up being something where it sort of worked fine with the thresholds that I'd set. I discovered that the Bluetooth stack needs quite a bit of runtime memory. It needs 128 kilobytes of free heap space. And so that was more than I was leaving available to the system outside of the Forth heap on a regular ESP32. So I've added a word called relinquish that releases the back end of the chunk of memory that gets allocated for the Forth heap back to the system, and that allows the B term entry point to release at least enough memory to for the system to run. So I'm able to call one of the internal words that lets you figure out how much memory is free to the system and see how much I would have to release in order to give up that 128 kilobytes that Bluetooth needs. The Bluetooth stack in general is a pretty sort of inefficient one on the system. It really grabs a lot of resources so in any event, if folks are interested in trying that and have hit troubles in the past, give it another go. In principle, it's very straightforward. You just do B. You have to build and do B term, and then you're able to connect to it as a Bluetooth device. This one I maybe will go pop out of the slides and give a demo. So I added some shell words. I found that you've got some local storage on the ESP32 on the SPF on the SPI FFS file system. And I found myself sort of feeling like, well, it's weird that I got this interactive thing, but I have to do quite a lot to see the contents of what's there. And I also for ESP32 Cam, it has a built-in SD card slot, and so that one you can also mount it and interact with the storage and the same thing. And so I've added some words that mimic Bash a little bit, just sort of the basics. And the only issue is that ESP32's built-in libraries, by default, they don't handle subdirectories, and so for the SPI FFS file system, they'll treat it a path name with slashes in it as if it's that's part of the file name. So there's a few words that I related to moving around in directories and so on that don't work the same on Linux versus ESP32. I haven't gotten around to adding it for Windows. There's actually some quirks in terms of how that would have to function, but I'll demo this. So I've added so there's for those that know, bash prompt, there's copy, there's move, there's remove. There's touch, which will create a file, an empty file, and then cat that will print out the contents of a file to the terminal. And most critically, there's ls to list the files in a given path, which is handy. On Linux, there's also directory-related words like cd and make dir and remove directory. I am a little bit tempted to explore emulation of some idea of a current working directory on the ESP32, but I'm also mindful that's going to just sort of add more junk to the baseline footprint. So I'm also kind of not sure if that's a good use of space, given that there isn't real directory support there. Interestingly, I was looking at the insides of some of the file system libraries, which come from the underlying ESP IDF system, and there is an option in there to enable directory support, but for whatever reason, on Arduino, I guess they have that turned off by default. So a bit of a mystery. So let's see. Well, let's pop out and do a demo. Let me actually, I will connect to an ESP. Let's see. I'm gonna load. I'll put this on there. Is that readable to folks? No, too small.
Too small.
Let's see. Let me change the way I'm sharing my screen. How's that?
Yeah, that's great.
That's good. Okay. So so the way these words work is that you can do ls, And right now there's only the blocks file there. I'll demo a thing that got added. I demoed this last time when it was in a little bit. It's not in that less of a rough state, but there's a visual editor now, so you can create a file. Let's say I call it hello.txt, and hello there. This is a test, and I can hit Control X and save the file. And now if I do actually, I'll just list the directory. Now I see that file. I can now cat out that file. Oopsie, I have to do the full path because it's there. I can copy that file. I can now do ls, and the file is there, and I can cat it out, and it's got the same contents. If I decided I wanted to rename it instead, I can and it renames. I can just create empty arbitrary files, and those will show up. And if I want to clean up, I can just do that, and so on. The visual editor, I've added some instructions on how to use it to the website, and so if the keystrokes are pretty simple, it's just arrow keys to move around. There's, I think, page up and page down. You're always in sort of an insert mode. There's this little weirdness about the two cursors, which I'll get sorted eventually, but for now I went with what was easy to implement, and then the main keystrokes you need to know are Control S will save, and Control X will exit, but it will also ask you if you want to save each time. And so I can save, and let's see. It looks like there's question. Is there a question in the chat? Let's see. Nope. Other stuff going on. So that's that. Let me switch back to the bigger screen. Code words. This one actually I had put it on the back burner for a while, just of the stuff going on, and it's actually got a lot of complex kind of wrinkles to it. So I've added code words. There's but the assembler is not yet ready and working. I use a C call signature to get a stable binary interface for code words. I'll describe what I mean by that in a second. And then one key issue is that on the ESP32, there's a distinction between data and code memory. And so you have to actually, I don't directly use a piece of memory in the Forth heap. I have to allocate a separate block of memory for code words. I've also added support for a version of this on Linux. There's actually similar in Linux. The issue is that you need to have the protection bits for the memory. You can use arbitrary memory for code words, but you would have to specify to the system that they're code, because otherwise it will be angry when you try to execute them. I will hopefully have an assembler of some flavor, at least for ESP32, coming soon. I had started it on it previously before I had the code word support, which is really the wrong order. It's good to be able to interactively test that you can that a piece of code works and to know the calling conventions of the system before you start working on an assembler, as it turns out. In general, this is lazily loaded by the ASM word, so you're typically, other than some memory in the system, you're not paying for this in terms of RAM unless you happen to execute ASM. There's code to define a word and code that ends the word. Because the code memory has to be separate, there's a C here word and a C a lot word, and then some words to compile code into the dictionary. The calling convention, the way it works is that there's a new opcode that transitions into a code word that's in the data the parameter area of the current word, and it calls into it using a C call, so that there's a fixed set of registers involved based on the ABI of the particular platform. So I believe I cribbed this, I think, from, I don't know if it's from G-Forth or there's some proposal for a different way to have a boundary on the edge of G-Forth where you pass in the stack as a parameter, the stack pointer, and then return it. And then for floating stack, which you often don't care about in most words, you pass in a pointer to the floating stack pointer, and that way there's the option of using the floating stack, but you're not sort of obliged to deal with it typically. And so on x64, this means that you get the data stack in on DI, but you have to make sure that it comes out in RAX at the end. And then the floating stack, you have an indirect hop to it on RSI. On ESP32, it's the extensa instruction set. Although actually, I should a caveat here. This is in theory, it all works for the C3 and the RISC-V stuff, but I haven't wrapped my head around RISC-V assembly yet enough to have really vetted that anything substantive works there. So you get A2. Actually, sorry, backing up a step. On extensa, there's many different ways to do sort of register management. The ESP32 has the windowed option, so it uses a calling convention where the set of registers it can use a sliding window, and then when you call into a function, it will sort of slide that window over. And so it works out that it does that in chunks of 4 registers. And this particular calling convention ends up meaning that because it needs to also include, I think it's the return address, and also I think there's a base pointer, but don't quote me on that. It ends up so that A2 and 3 come in as the stack pointer, and then A2 is the path out again. And so that ends up being pretty handy. I think for a 4th word, at that point, that means you have basically all of the registers free, other than these. Well, you can't touch A0 and A1 either, so otherwise you can't return. So basically, A4 and above are free for use. This is what the transition looks like. It's a bunch of C gobbledygook, but the net result is that you can, if you put in code directly, you can the bytes for the code directly. You can build up a word. So like this is doing a ×2 where you need to copy over the stack pointer from RDI into RAX, and then it's shifting. It's worth mentioning that in this transition, where normally ESP32 Forth keeps the top of stack in a separate variable, it does away with that to simplify things on the assembly side. So the stack is fully based on that stack pointer, and there's no cache top of stack. So anyways, then you're able to shift the indirect value in RDI and then return back. And similar story on extensa. You do have to have the standard entry. I think the 32 is 32 bytes, and it's doing the shift of the window by four elements. And then here it's using A8 as a temporary register, loading in that stack pointer loading indirectly through that stack pointer, doing a shift in A8, and then storing it back out, leaving A2 alone. So I've also, the dump word previously was not column aligned, and so now if you do a hex dump, you'll actually, get things lined up before it would give you kind of a pretty junky dump. It probably still could use some polish in terms of offering a nicer dump, and I don't think it does anything great if you're in decimal mode. So, I mean, you can use it, but it isn't particularly readable. So that's another incremental improvement in that regard. Please stop me if there are questions and shout out. I do not mind interruptions. I see there's things in the chat, but ESP32 Cam, one of my own projects is I've been slowly working on a set of Wi-Fi connected cameras. The ESP Cam offers a version of the ESP32 with a built-in SD card and a camera. So there's a bunch of bindings that have been there for a while to access the camera and capture a frame in various formats. I've made these richer because as I dug into the project and wanting to be able to control some of the dynamic parameters like white balance, I wanted to have access to more of the library. Basically, if you go to the ESP4th website, this is all documented, but there's basically a ton more bindings. So there's sort of constants for all the pixel formats and knobs for the quality for JPEGs and things to access the buffers and just tons of bindings. So there's nothing sort of substantively different other than that I believe it approaches having all of the bindings that you would need to be able to fully interact with the camera and choose sort of all the different things. And then the last thing I'll cover is something literally got added last night because Peter asked a great question. For a while, you've been able to expand the system using the user words file to add user-defined words, so you don't have to fork the output of the build. But if you wanted to put those user-defined built-ins in a vocabulary, there wasn't really a way to do that. So you would normally define a word, with Y or X. You'll recall Y if the word is a C identifier and X if it has special characters. Unfortunately, that's the tersest syntax I could come up with. There's a variant of this that supports vocabularies, and this is used internal to the system, but it's now feasible to use it inside of user words. It's a little bit confusing. It's not actually directly going into a vocabulary, but it's going into a kind of a weird construct of my own creation called a built-in. And the idea with a built-in is that it's a sort of a magic word that's an extra. Whenever the dictionary scanning crosses that word, it attaches a static set of words that are built-ins to it. So I'll describe what I mean. So, for example, there's this. If you've ever done VList and looked at all the words, you'll notice that there's a word called internals built-ins, or there's a Forth built-ins as well. And that word, wherever it sits in the in a vocabulary, if you pass over that word, it will cause all of the built-ins for that type to be searched, and so that allows the possibility of defining a bunch of built-in words, but keeping them largely in flash memory instead of using up RAM for all of their headers, but then preserving the ability to move those words around between different vocabularies after the system starts. So what you would do to use this if you wanted to add words that were not just up in the Forth vocabulary is you'd want to add a user-defined vocabulary, or rather than this is, again, a bit of a misnomer, a built-in. So my vocab and my vocab2 would be a built-in, and then you can use the V variants of these words to add those words in to that built-in. And then that doesn't actually create the vocabulary. At start time, you have to actually create the vocabulary and then transfer in the dash built-ins word that has all of those built-ins dangling off of it. I may, please send me feedback on how this works. Part of why the ability to move these around is useful is that the core of the system initially makes assumptions that a bunch of words actually live inside of all inside of the Forth dictionary at startup, and that's because vocabularies themselves are not sort of fully there until they're defined in higher level words, and so it ended up being I needed a way to have words that could be built in that are in a vocabulary, but that start out somewhere that they're reachable. So kind of a bad design constraint on the system that sort of bubbled through to the user. But if you are eager to use vocabularies for extensions, this is what there is right now. That's all I've got for this time. Are there questions or comments on any of that?
Thank you very much. Well, that's actually quite a lot. Amazing. Yeah. And it's really evolving. So are there any questions?
Yes, I do have a question. Brad, why did you choose not to go for ANS word sets instead of vocabulary?
So, sorry, I missed the first part.
Why did you choose to go for vocabularies instead of ANS word sets?
Word list.
Word lists, sorry.
So to be honest, originally I was looking for something that I could sort of bootstrap. I didn't have the intention to fully do proper vocabularies originally, and now that they're there, it is a good point that maybe the ANS word lists would be sort of a better place to land. I think that initially I had an earlier prototype that preceded the ESP32 Forth. I had done an experiment where I was trying to support redefinition of words similar to what Jupyter Ace Forth allows, and Jupyter Ace Forth used sort of old style vocabularies, and at the time I found that amusing, and so as I've used them more, I'm less sure that it's a good pattern, and I'm now beginning to think that the direction the standard evolved in terms of word lists might be better, but yeah, definitely something that might be worth reconsidering. So I guess the evolution was I was using Forth79 style vocabularies because that I was sort of mirroring Jupyter Ace Forth on a predecessor of ESP32 Forth. Then when I initially didn't have vocabularies in ESP32 Forth, so when I added them, I sort of cribbed from the implementation in that prior version, and then things got out of hand quickly because it became apparent, oh, well, we need all these bindings. I need them in vocabularies now, and soon I was sort of committed in that direction. That said, I do kind of, I think part of what got me exploring that Forth79 style type of vocabulary, there is something nice about the layering that it does by default. So, but that could be built on top of word lists. Word lists are very flexible, and so, yeah. I don't know if that answered your question.
Yes.
Kristen has one. Brad, when you created the assembler for ESP32 Forth, what did you have in the back of your mind? Because you could do everything in C. What was it that you had to do in assembly?
That's a good question. So in couple different things actually. One is that I am actually a thing that I have found sort of concerning about ESP32 Forth is that and ESP32 in general rather is that there's a lot of black magic in the underlying system, and I've played around a little bit with poking some of the registers that let you manipulate, say, like the I/O ports directly, rather than using the C bindings. But I think that I've been take the Bluetooth stack for example. It's it's a huge library that takes over half of the capacity of the system to use it, and so I've kind of wondered whether there's what's going on there. So to be honest, part of my motivation is less that I'm interested in an assembler, but more I'm interested in a disassembler to go poking around into some of the built-in facilities of the system. So that's I think also sort of slowed my progress there, is that I'm trying to build both a dual assembler disassembler. The other thing that I have sort of on my agenda, why I'm sort of interested, is that I've got some prototype of doing machine learning code for on desktop that I eventually intend to try to bring over some small neural networks to the device. And so I have this worry that I'm going to hit performance bottlenecks when that comes. But the other thing is just curiosity. I kind of have been interested in the Extensa instruction set, and have wondered, it's not one that I had seen previously in any context, and so I've been interested to sort of learn more. It's a pretty simple, nice instruction encoding, and so it's sort of tantalizing that it's there. But you're right, I think in terms of practical things, being able to extend it in C is probably more practical, but I think it's that allure of, well, if I understood this board better, maybe I would do a pure native Forth on it and not rely on the C compiler.
It answers my question. Thank you.
Right. So, are there other questions?
Thanks, Brad.
So, yeah, I can only encourage everyone, try it out and give feedback. So it's actually a system that grows significantly and gets better and better. So that's quite good. And I think Brad is happy about any feedback that you can provide.
Yes, indeed. Oh, and I should say, I forgot now who it was in the meeting that suggested invoking Arduino build. But I've been during the meeting, I've been puttering with that and getting dangerously close to having it work to be able to run the Arduino tools at the command line, and that actually will be a great convenience to me, because it will save me steps in terms of testing it on for the different board variants. So thank you, whoever it was that suggested that. That's a great suggestion. I was able to crib the command lines and sort of tease apart the pieces, and thank you. That was very helpful.